Dear students, welcome to my YouTube channel Unique Physics by Ajay Sir. Here we explain 11th Physics, chapter number 1, Physical World. Last time we explained two fundamental forces in nature. Number 1, gravitational force, and number 2, electromagnetic force. Here we are going to explain a third type of fundamental force, that is strong nuclear force, SNF. Here we start this topic from a definition of strong nuclear force. So what is called strong nuclear force? This is simplest definition. Remember this definition. The strong attractive force which binds together the protons and neutron in a nucleus is known as strong nuclear force. We already know that nucleus contain two particles, proton and neutron. The attractive force which binds proton and neutron in a nucleus is known as strong nuclear force. Now remember important properties of strong nuclear force. First property, it is strongest force in nature. This name suggests that it is strongest force among all forces. Second property, it is short range force about 10 raised to minus 15 meter range. In definition of strong nuclear force, we consider nucleus, and size of nucleus is very small, about 10 raised to minus 15 meter. So it is short range force and its range is about 10 raised to minus 15 meter. This is size of nucleus. Next, it is attractive force for specific distance. Remember this point. Here strong nuclear force binds proton and neutrons. Clear? That's why it is attractive force for specific distance. Next property number 4, it is non-central force. Next property number 5, it is non-conservative force. Property number 6, this is important property, one of the important property of strong nuclear force. It is charge independent force. Charge independent force means force between proton, force between proton neutron, and force between neutron and neutron are equal. Clear? We know that proton is positive charge particle, neutron is neutral particle, but it is independent of charge of particle. Seventh property, the exchange particle for strong nuclear force are pi mesons. And property number 8, electron do not experience strong nuclear force because electron lies outside the nucleus. So electron do not experience strong nuclear force. Now remember important point for strong nuclear force. Here we consider strong nuclear force act between proton and neutron, but advanced study suggests that proton and neutrons are made up of quarks. So force between quark is called fundamental force. So we can say that strong nuclear force is not a fundamental force but quark force, clear, is known as fundamental force. Thanks. Now fourth types of fundamental force in a nature is weak nuclear force, WNF. This is last type of fundamental force in a nature. Remember first point, this force appears in certain nuclear processes. It means this force appears during certain nuclear reactions only. And remember one of its example is beta decay process. So this force appears in certain nuclear process like beta decay process. Now what happens in beta decay process? So in beta decay process, nucleus emits electron and neutrino. Remember name of these two particles. Nucleus emits electron and neutrino. The electron and neutrino interact with each other through weak nuclear force. So weak nuclear force produced between electron and neutrino when they emit from nucleus. Now remember properties of weak nuclear force. First property, it is short range force about 10 raised to minus 16 meter range. Remember this point. Clear? This force is associated with nucleus and size of nucleus is very small. That's why it is short range force. Next property, number 2, it is stronger than gravitational force. Remember this point, gravitational force is weakest force. So this force is stronger than gravitational force but weaker than strong nuclear force and electromagnetic force. So compared to strong nuclear force and electromagnetic force, this force is weak. Number 3, here we consider particle neutrino. So remember important point for neutrino. Neutrino is massless and chargeless particle. Mass of neutrino is almost 0 and charge is 0. And advanced study suggests that the exchange particle for this force are boson. Clear? And here the name of boson was given by an Indian scientist S.N. Bose. Thanks. Now remember last table of this chapter. We have four type of fundamental force: strong nuclear force, electromagnetic force, weak nuclear force, and gravitational force. Here the relative strength are given. Clear? And the range are also given. Relative strength. Suppose the value of strong nuclear force is 1. So compared to strong nuclear force, relative strength of electromagnetic force is 10 raised to minus 2. Similarly, strength of weak nuclear force compared to strong nuclear force is 10 raised to minus 13. And strength of gravitational force compared to strong nuclear force is 10 raised to minus 39. In some book it is given 10 to the power minus 38, but it is almost equal. Now range are also given. Strong nuclear force acts within the nucleus, so its range is 10 raised to minus 15 meter. Electromagnetic force is long range force, so its range is infinite. Again, weak nuclear force associated with nucleus. Clear? Because nucleus emits electron and neutrino, so its range is 10 raised to minus 16 meter. And gravitational force, this is long range force, so its range is infinite because gravitational force act between sun and earth. Distance between them is large, so range of gravitational force is infinite. Thanks.